Hello, hello, and welcome back to the part two of the episode two of Agents versus Human. My name is Shubham, and the reason I'm here is because I am trying to upskill myself to learn more about AI, the tech stack, the business, the relevance, the use cases, and everything else that comes with it. And as I go through this journey of learning more about I thought, why not build some videos to share everything that I'm learning? And again, I am not an expert yet, but I'm hoping that by the end of the series, by the end of our journey, I would know enough to talk intelligently about AI, to find use cases, to be able to build solutions using AI in my day to day and in my profession. And so I hope for you. So today, I know last time we talked about like what are agents, what do they do, and stuff. So thank you for all the comments and questions and stuff. So I'm going to, at the end of today, I'm going to probably try to see if I can answer some of them or comment on some of them. But today I did some research and I used an app called gamma.ai to build a quick presentation that talks about the key concepts in AI, and also just tries to give you a little bit of introduction to language. Like every big tech stack, or every framework has some sort of a language, and you should know the you know key principles in the language. And let's talk about those today. I will also talk you through about what you should know about AI, what are the pieces of the puzzle, and how they impact the overall game of AI. And then we will end by just talking through visual representation of the tech stack that I found on a very, very good blog. I have a link to the blog. I can share it in the description if some of you guys would like to read it further. So let's start without further ado. All right. So oh no, see, how do we make it? All right. So I hope you guys can see it. Let me move myself to the other window so I can see myself. There you go. So key concepts understands the basic and build confidence in AI concept. Something, yeah, I wrote. I didn't even write it. Pretty good. So let's start. So this, by the way, these numbers are why you should learn more about AI. These numbers I found out of an AI report generated by McKinsey, and you can see, right, like what is the impact? It's a $4.4 trillion by 2040, which means that there will be insane amount of money pouring into these systems, which also means that if you do not learn more about AI, if you do not learn how to use AI, how to have AI work for you, you will be left behind in this race, right? And most of this, you can see where it's coming from. It is 70 to 80% efficiency and 40% productivity boost. Now, here's the misconception that I think people have, right? So people do either binary decision making, where you say, okay, maybe there are a lot of jobs that will be lost, maybe there'll be a lot of jobs that will be created, right? But what people forget is that it's not that binary, right? What's going to happen is, with the productivity boost that comes in, with the increased efficiency that comes in, there will be more jobs created, but they will be very highly technical jobs that require you to understand AI, because AI is going to do the work. How that happens, let's tie back to a previous lecture which we talked about agents. Now what think about it, right? So you have three agents that are doing some stuff, right? Let's say they are basically writing, they're analyzing the market, they're writing really good blog posts and social media posts, and then they're posting it. Now they do the work most of the times, but they do break like any machine breaks, right? What you need is people who understand how to operate them, how to fix them, how to work with them, when to stop them, when to not stop them, when to put checks and balances, when to look at an output and say something is going wrong, who to reach out to get them fixed. All of this skill set needs to be there. That's how you get this efficiency number here, right? You're getting the efficiency number not because that one person that is sitting today can do more. That might happen, but it's because there's a 5 people team that shrunk to maybe a 2 people team, but they are now able to do twice the work of that 5 people team. And that is where you need to upskill yourself, because that means that if you do not know or understand how AI works, you will not be that one person that is leading a team of agents. And that's why you should learn. All right, what is artificial intelligence? I think a lot of us know about this because I did talk about it last time also, but I just wanted to refresh through some of the basic um, basic terminologies, right? So AI simulates human intelligence. Yeah, we all know that. Now AI is nowhere near actually being like thinking like a human. Just nowhere near. But what is happening is it can simulate very, very close to, what you could call an automated system, but it also adds another layer of a little bit more intelligence on top of it, a little bit more conceptual ideation on top of it. And that is why AI is a little different than where we were 10 years ago. It also learns, which is another thing. A lot of automations are dumb. Automations don't learn, right? And so that creates another layer of saying, oh, I made a mistake. I'm going to figure out what happened and I'm going to get better. That causes the AI to get consistently better over time. And then it can act, and then that autonomously acting, it did exist with a lot of automations, whether that's where automation comes from. But what makes it way, way smarter is the first two things, because once you combine think and learn with act, man, you have something really, really powerful. And again, you don't need to put AI in charge as a manager. That's not what's going to happen. AI is going to replace the minuscule task. You'll have agents that are doing very, very, very specific things, and then there's like a layer above that is all like orchestrating these small things, and then there is people like you, me, somebody else who knows how these things work, who can, make them, break them, who can change them, who can like think about and like a big giant manufacturing facility today. Most people in automated facilities are not really doing things. What they do is they make sure that things are getting done, because a lot of those robotic arms are doing things because they're faster, but guess what, they break. They do the wrong things. Their internalities change, right? Yes, they will get smarter, but they'll still break. They will have and that's where your opportunity is, right? What is machine learning? Again, another huge thing that you should understand, and it's more of building a vocabulary around AI, because people just confuse machine learning with AI and like fuzzy logic, and they're just like an agents, and like it's just, I think the better you understand the differences between all of these terminologies and what they are and where they fit in, you would sound smarter in a meeting, because you can point out to people not everything is AI. And that's, I have to do this over and over again. And I think some really smart guy talked about this in one of the comments, that ultimately a lot of this is AI, right? A lot of this is machine learning, right? You put machine learning techniques in place and put a large amount of infrastructure below it, and voila, you have massive amounts of models that can now churn out insanely cool outputs. Now, that said, if you knew machine learning is built on top of statistics, then it's really math. Statistics is math, right? So it's probability and statistics at the bottom. And so that, like, ultimately this is a stacked thing. And so you should understand where and what you're using. Sometimes you would just be using basic machine learning. It is not going to be AI, because it's not going to do anything out of the box. It might just say, oh, predict a color. That's not AI. That's just machine learning, right? Like you could basically train a model to say out of 5,000 images, can you predict which one works best, and give it give it data on like which colors work best in the background. And there you go, it trains itself, and it will use probability to predict, and you can fine tune it to go up to like 90% of the time. It'll tell you the right thing, and then a human can check on top of it. So what is machine learning? It is data collection and preparation. It's very, very important because you need large amounts of data. Usually you train a model by saying, I'll create a set of data that is the training data, and then there's the testing data, and you basically train the model on that, on some amount of data, and then you run the test on the rest of it, so you can see how it's predicting. It's model selection training, right? So there are multiple different algorithms that exist that you can use to build a model, and then you can train the model. Evaluation and fine tuning, which it talks about, right? With model evaluation is how is the accuracy, how, and then to predict the accuracy, you need a set of data that you already have run the model on, right? Which you know the answer to the data. So for example, let's take a very concrete example. I need to say every time I have a product image, for example, I have a shoe, I need to put some sort of a colored background behind it. Now I know that a white shoe will not look good on a white background, and I know there are thousands of shoes and thousands and millions of colors. So how do I do this? What I do is I take the combinations of, let's say, 10,000 or 50,000 outputs where shoes and the background colors are matched and they look good. I take human annotators to say, all right, I am going to annotate when a shoe looks really, really good. Now when I have that data on the background, when I have the data, I divide that data maybe in 50-50. It depends on the circumstances or how much data you have. Sometimes you do 75-25. So 75% of the data will be used for training, and 25% of the data will be used for testing. Now you already have good answers, so you start training your model on the 75% of the data. It's basic mathematics. It understands when and how to predict the background that looks good if you have large enough set. And then it uses statistics and probability to then again try to predict what the new product background should be. So that's how it works. And then there comes the deployment and iteration. A lot of this happens on cloud-based systems. I mean, we currently use mostly cloud-based systems to do that. So machine learning is really like a part of the stack. Like it's one piece of the puzzle, and you should understand which piece of the puzzle it is. That's why I'm trying to tell you where it fits. Automation. What is automation? I mean, you can think about manual processes in the background, right? So there is a lot of I'm not going to spend too much time here, but I think just generally speaking, I've talked about this before, that there is Excel was a way to automate a lot of the mundane tasks that you would do on accounting or numbers, right? And so then you can save those formulas, and now people use sheets as automation, right? It has no intelligence per se built in it because it's based on mathematical formulas, and it's very predictive on saying a is equal to b plus c versus d is equal to b minus c, right? And always do the same thing. It right now, the manual processes are very hard because you do that mathematically and you do that with a calculator. You'll have to check it 15 times. They're slow, they are prone to errors, versus once you automate a lot of these things, it improves the efficiency. Now, we all know about this, so I'm not going to go through too much about it. So AI, ML, and automation. So AI is the overarching concept, as I said, right? But machine learning is what enables you to learn from data and to be able to create that like predictive mindset, right? But the automation in the back, it allows you use AI and machine learning in like maybe like an agent, as an agent, or use some sort of other modeling tools that allow you to take a human task and automate it, because now the learning system, the data have come together for you, and because AI is literally like has and I'll show you what that diagram talks about. It has data in it. It has the data cleaning. It has the data learning from the data. It has the model. It has the model fine tuning. It has other like infrastructure behind it, right, which is the hardware. It also has the scaling, right? All of that sits behind something that then sits behind an API that you can then call and then build applications on top to automate things. How? One big example that all of us use is if I have to write a blog post, I can now go and talk to ChatGPT. ChatGPT automated the writing of the blog post for me. So that's where the automation meets like AI and machine learning. Real world application, AI assistants, and you guys have known for a long time, right? Now, AI assistants, they they kind of like learn, they understand natural languages. So that's another like part of this whole kind of system, which is the natural language recognition and the natural language generation, right? Processing and generation, NLP and NLG. And which means that can I take a statement made in a natural language, which is the conversing language, and then give you and process it, understand what happened, run the model through the data that I have, come back and say, here's the answer, structure that answer in a way that is again in a natural language, which comes natural language generation, and then say it back to you. That's the number of steps it takes. Now, what has happened in the last couple of years, I think, especially because of these devices and AI assistants, is we've gone really, 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 really good at like natural language processing and natural language generation, which means that now you no longer need to have a standard output coming out of uh, a standard output coming out of like a machine, right? Which means that the machine now feels more like a human because it can actually produce outputs more like a human. It can talk to you in a natural language, and that again pushed this whole AI conceptual AI stack way forward. That's how ChatGPT works. You can chat to it. It feels like you're chatting to a person. A Netflix recommendation. Again, this is important because you have to realize that this is not like AI, right? People think this is AI. It's not. It's pure machine learning, right? What you do, and I do some of this myself, is what you're doing is saying, oh, I have a data for 1 million users, and every time I find a user that likes, Die Hard, the movie, and also a few Get Good Men, the movie, I know they will likely like to see more either action packed army or action packed army history movies, right? And so you can suggest movies like We Are Soldiers. In I could have done it, right? If I sat down and if I looked at all this data, if I had like 500 more people look at this data, I might have to be able to do it manually. But what I did was I used machine learning to build this model, train this model, test this model, tune this model, put it in production, and now that model is exactly doing the same thing for my users without human intervention, but still not making any intelligent decisions. It's statistics, it's probability. It's saying basically the answer of such a model is, I think, because this person likes, romantic movies, and this person also likes, family movies. During Christmas, they will like Christmas movies. And that is a probabilistic answer. Nobody can say 100%, but they're saying on 90% of the times, people who like these two like X. And so that's how I show recommendation. There is no AI. There's no like thinking behind it. It's more just probability, right? And so that is why not all of your recommendations you like, because it's probability and they know it. But they're getting good at it every time you click because they are trying to learn from it. That's where machine learning comes from, because you are now, they take that data and say, oh, I gave them 16 suggestions, they didn't like it, why didn't they like it, what did I do wrong? And then automated supply chain, again, robotics are just getting so much better at doing this. Now, one thing, other thing is that when you do robotics, you also combine things like robotic vision, right? So computer vision comes into play, which allows us self-driving cars to see, robots to see, cameras to see, our phones, right? The reason why my phone can now look at me and like actually unlock when I look at it is because it literally can take a visual measurement of my face and say, oh yeah, this is the same person. That's computer vision. This is what I was talking about. So this is the stack. If anyone ever tells you AI is one thing, just don't. I think there's a blog post link here. I think you should read it. This is how complicated it is, right? And to be able to really truly understand AI, you should spend time thinking through each one of them, learning each one of them. That is my reason of doing this, because I want to go through each one of them slow and steady, and I want to talk about each part of it, and that'll help me learn and that'll help you learn. And hopefully this will also allow you to understand the nuances of these systems, and you don't talk about them as if they're just one thing. So let's start here, right? See how it's like, there's data storage. Data is extremely important, and you wouldn't believe why computer vision got so good. Part of the reason why computer vision got so good in the recent history, and we are also able to do things like stable diffusion and train those models, is because Instagram exists, it's because Facebook exists. So think of all those photos that were uploaded to Flickr, to Instagram, to like free web. It's all training material, right? Now, because you had millions and millions and millions of photos, you will have train data. That's not it though. You need data processing, so you need better infrastructure, right? You need like much more robust cloud infrastructure, high amounts of processing power, GPU chips. You also need better algorithms, which has happened over the last, and we'll go through those algorithms too, or we can possibly at some point talk through the paper, the more famous paper from Google that led to OpenAI's ChatGPT. Is the deep learning, and this is the concept I want to learn more, and maybe we'll build some more, really good presentations around this. Natural language understanding and sentiment analysis, right? Again, I think I would just add generation to it too, but sentiment analysis became huge. Twitter did that. Twitter was probably the first time I heard about sentiment analysis and the way it worked. And see how interesting this is, that each one of these technologies, they stood up separately, right? But there are scientists who are now trying to move them. So when I heard the first time, basically what people were doing was, Twitter was big in 2012, 13, 14, and people figured out that a lot of the tweets on Twitter can help you understand how people are talking about your brand, which means that if you analyze them, this is basically a way for you to know if your brand is doing good or not. And that's sentiment analysis. How are people feeling about your brand? And that's how sentiment analysis came to be. Now, that is today used when you talk to Foro. When you talk to Foro with your voice can tell if you are, kind of happy, not happy, with the construction of the language that you have, because those models were trained on like humongous amounts of data, petabytes of data, and they understand. They now know how and where humans use what words in what sentiments, and that tells them, and they've got really good at predicting your sentiments. And so now, like, you could use sentiment analysis in places like this. Visual interpretation recognition, again, very important. Robotics, and then cloud. I cannot tell you how important. And one part that's missing, I wish they added it, is the basic infrastructure of GPUs. It is insane how important those GPUs are today, because those GPUs, if they did not exist, we would not be able to process the amount of data that needs to be processed to do generative AI. And so you can see how, like, these set of technologies are actually kind of building themselves separately. Each one of them can be used separately, right? For example, data organization, data processing. Where did it come from? It came from big data. That was like a huge thing in 2000s, right? We all went through big data. Everybody was processing data. We didn't know what to do with the data in terms of algorithms, but we were processing data and trying to get like good insights out of it. So each one of them came up separately, and now, as they're kind of getting more and more complicated, people have also started to figure out how to make them work together. And there you go, voila, AI. AI is not one thing. AI is a set of all of these things, and we in this podcast are going to go through each and every one of them slowly and steadily. Conclusion: AI thinks. We learned that today. There's a difference between AI and automation. Machine ML learns and the automation acts. Oh, by the way, this is written by AI. I didn't write it. So this is pretty good. And I told it to write like something that like gives you guys like a sense of like takeaway, right? I'm trying to also make these easy to parse because I also see that when you go to Coursera, and I'm learning on Coursera too, it's those, it's not bad. It's just that those concepts are very hard to consume if you don't want to be a computer scientist. And the problem is, I think there's a path in the future where a lot of people who are not computer scientists, who don't want to code, who don't want to like be close to the nitty-gritties, will also need to understand how all of this comes together, how all of this works, because they will use these AI agents, they will use this AI, and it'll be very important for them to understand why and how and what happens. The reason why prompt engineering exists is because what we talked about today, because NLG and NLP exist. But guess what? NLP is only so good because it's like, it really looks at the way you've written your prompt to understand what to give you. And if you really write good prompts, it can understand you better and then it can give you a better answer. That's why prompt engineering exists. So this is all for today. I hope you liked it. I'm going to keep doing these over the next couple of months, maybe years, I don't know. But please reach out to me if you have any questions and stuff. One thing that I wanted to quickly talk about before I end: somebody said, right, people don't understand that this is all just models, and that's true. And the thing that I would like to just address is, yes, like there is a thing called abstraction, right, in tech. And what ends up happening is every time like something gets really complex and like more than one fundamental um uh, uh, fundamental like theories come together, or like technologies come together, people create an abstraction on top of it, right? And so yes, AI is data processing, AI is machine learning, AI is a model, AI is predictive, right? All of that. AI is NLG, AI is also NLP, right? But then guess what? Machine learning and NLP is statistics, right? And statistics is math. This, the, all of these statements are true, but that does not take away from the fact that AI is the rapper. And you will have those AI agents will be the rapper. They will combine automation, tool, data, and the thing which is the LLM, which is going to be the brain, to do things. And that's why they call it. And you can't explain these easily possibly to people, and that's why you need abstractions, because then you give it a name. You said, oh, I'm not going to say these 5 things every time, I'm going to call it an AI agent. And I think that's why AI agents exist, because you're right, they're literally models in the bot, but you can't explain all of this to everybody. The AI agent is much easier to understand for somebody who's not coming from a technical background. That's my answer. All right, thank you, and we will talk soon.